Hey everybody, back for 11.2 I see. So right now, 11.2, if you would open your book or have your book open near you somewhere, if you don't remember how to get to your book at this point, make sure that you talk to me so that I can get you your login stuff. But if you have your book, go to page 604. All of the examples that I'm going to be doing come right from the book, and obviously you've seen my handwriting at this point and you know it's not great. So just understand that I'm not going to be writing every single word down from this. I'm just going to be kind of pulling bullet points. So if you miss something, just rewind it. If you can't understand what I'm saying, then just, open your book and look at your book because it's all in there. So this is 11.2, and this is about populations, samples, and something called hypotheses, which all of you know what that is already. So hopefully this is a quicker lesson. A population is it's a collection of data. So a population is working for, collection of responses, it's questionnaires, it's just a collection of data. And it's basically what you want to know information about, right? Like if I wanted to know about the junior class, and I asked 15 people from the junior class and I wanted to know about them, the population is the junior class. I'm collecting data about the junior class. A sample is the subset of people that I'm going to ask, because it's going to be almost impossible for me to ask every single person in the junior class a question, right? So I might ask 20 of you a question. The 20 of you that I ask are the subset of the entire population, which is a junior class. So in your book, on page 604, there's a question that says, in the United States, a survey went out to 2,184 adults that were over 18. Of those 2,184, 1,328 of them responded that they owned at least one pet. So there were 2,184 people that were asked, and the 1,328 responded that they had a pet. So basically, which one is a subset and which one is a population? The population are the population are the people who are 18, right? All 18 Americans. So when we look at the population, 18 plus Americans. So if I want to know what the population is, I asked 2,184 people whether they owned a pet or not. I wanted to know, the information I wanted was the 18 plus. So actually, hang on. So what is the population? The population is all Americans that are over 18. That's what the population is. 2184 is not the population. So it wants to know what the sample size is. So if I want to know what the sample size is the number of people that I asked. Okay? So if I want to know what the sample size is the 2184. So really that 1328 doesn't tell us anything. It's really not much. Okay? So since that's really not much, that's really, it's not information that's helpful to us. The next vocab word, and this chapter is basically all vocab, so that's basically what this is. The next one is about a parameter. And a parameter is a description of a population. So a parameter is a description of an entire population. Okay? So when we think about that, we are talking about we're talking about the entire population of someone. So if I talk about an average SAT score, an average SAT is a parameter because we are talking about every single junior that took the SAT. Right? We're not breaking it down into Frankenmuth kids, we're not breaking it down into something little. We are saying every single junior took this. So that is a parameter because we're talking about an average for the entire population. Okay? If we talk about a statistic is a little bit different. This is where we break statistic. This is where we break down what would happen with like Frankenmuth kids, right? So we would say, so this is a description of a sample. And the description of the sample, if we talked about Frankenmuth SAT, this is different because now we're not talking about every single SAT. We're talking about the Frankenmuth juniors' SATs. So this represents that this would be a statistic because we're talking about a sample of the entire population, right? The average SAT is talking about every single junior Frankenmuth's average SAT is talking about the juniors in Frankenmuth, which is a subset of all of the juniors everywhere. Okay? So that's what we're talking about with that. Getting to a hypothesis, you all know what this is. A hypothesis is a claim. Man, I cannot write on this thing. I apologize to those of you who have suffered through so many of these videos. It's a claim about a population. So we're talking about, like, we want to know, a hypothesis is something where you can kind of start to guess what's going to happen. Like, if I had to guess about the SATs for Frankenmuth High School, I would be able to make a guess because I have some sort of idea of where we're going, right? So now, like, for instance, a drugstore makes a claim that they see weight loss, or they have a drug company pushes out a drug, and they say, well, we see that we have an average weight loss of 24 pounds in 3 months. So this is saying that people are down 24 pounds in 3 months. This is a hypothesis. This is not true for everybody. This is not something that they can really prove. This is not something that, like, every single person is going to have different reactions. But to make themselves sound good, there's a hypothesis. So I'm going to say that the entire population can lose 24 pounds in 3 months based on a very small amount of information. Okay? So that's just something to kind of think about. Obviously, the closer that things are to the closer that things are to 0%, the less likely they are to be true with a hypothesis. The closer they are to 100%, they're more likely to be true with a hypothesis, right? Like, if I said every single person in Algebra 2 is going to pass the SAT, or is going to meet the benchmark for the SAT, then okay, boom. Right there I've said 100%, which means that's probably likely going to happen. But if I make a hypothesis that says nobody's going to pass it, it's probably not. They're probably not going to pass it, right? So that's just something to kind of think about. So the very last thing, if we want to talk about like hypotheses and we want to talk about this other stuff, this next thing that I'm going to talk from is from example 3 on page 606. So if you're looking at example 3 on page 606. Basically what this says is we're making a solution, or we're talking about a hypothesis for this. I'm rolling a 6-sided die 5 times. So I'm rolling a 6-sided die 5 times. Now, the probability of us rolling the dice 5 times and not getting an even number is pretty unlikely, right? Because there's 3 odd numbers, there's 3 even numbers, so the probability of me rolling an even number, or an odd number this many times is going to be 3 over 6 times 3 over 6 times 3 over 6 times 3 over 6, whatever, and this is going to be pretty significant. This is actually going to break down to 3.1%. Pretty unlikely to happen, right? So there's the hypothesis. So if I said that I was going to be able to do that, that's not going to happen, right? So then if I see this and I say, okay, well, I did roll the dice 5 times, and this did happen, I'm going to make a hypothesis and say, well, maybe these dice are loaded. Maybe something about them is not right. So I'm making a hypothesis based on my 5 things. Maybe I did this. Maybe I was successful in rolling these things 5 times and it didn't come up even. Okay? But then, the more I test this, if I do this 50 times, imagine doing this number 50 times and how much smaller this number would end up being. That's not likely. It's not going to happen. This number is already significantly too low to say that this is true, but if I do this 50 times, we're talking about 0.0000000, and so on. So many times we're seeing that number happen. So you're going to notice that when you see these things, your hypotheses are going to be true when they're closer to 100%, and they're going to be very close to false when they're closer to 0%. If I roll a die 50 times, it's very unlikely that I'm going to have a 50 times where it doesn't come up even. It's going to come up even sometime because statistically it's going to happen 50% of the time. Okay? So, in your book it actually talks about what the probability is and what happens if you rolled 26 odd numbers and what happens if you rolled 35 odd numbers. But so on and so forth. You can see the actual difference with percentages. You can see how the percentages work. So always back your hypotheses up with an actual percentage that goes along with it. This chapter was a lot about vocab. Basically all it was introducing populations, it was introducing subsets. We're going to get more into how you can draw conclusions from that stuff in a couple chapters from this point, but the next couple sections, the next couple sections are a lot about vocab. So just kind of keep in mind that vocab is going to be a big thing here. We're going to keep talking about vocab over and over and over again, because once we get past the vocab, it's all analytics at that point. Okay? So, short video. Don't kill yourself on homework on this stuff, because it's really not awful. Just make sure that you understand, the difference between a population, the difference between a subset, the difference between parameters and statistics, the difference between when a hypothesis is true and when a hypothesis is false. That's basically all this section is. Okay? So if you have any questions, shoot them at me. I will be more than happy to answer anything that you have. Be sure to let me know whether or not things make sense. I look forward to hearing from you. I'm getting pretty bored over here, so make sure you say something to me. All right, we'll see you later.